Alright everybody, last topic we have in this chapter is writing and graphing equations for circles. Um, these equations could come in handy if you ever chose to use some kind of software that used a grid system, and you were trying to put circles onto it for whatever reason, maybe as part of your design, um, or, whatever you're working on, maybe it requires circles to be used. Um, And it's going to be a nice little tie-in with algebra that we have. So a nice connection to your past. All right. Also, you could easily see it in some future math classes. So making our standard equation, we're going to use variables for the standard equation. And, those are things that we might know values of in problems that you see, things like that. So I'm going to, in this picture to the right, just sort of write down variable names for certain things that we have. And I'll show how those exist in the equation. So first thing we're going to look at is the center here. And I know that right now on the circle it's at 0, 0, but like I said, we're making a standard equation, so I'm going to use variables. I'm going to call the center hk, h being the x-coordinate of the center, and k being the y-coordinate of the center. For our equation, we're also going to need to know the length of the radius, which remember is going from the center to a point on the circle. I'm going to call that r for now. And let's call the point on the circle xy. It could be any point on the circle, any pair of xy coordinates that are on there. So with these three things, the standard equation of a circle is going to be x minus h squared plus y minus k squared equals r squared. And you're going to see that play out in a few of the examples, but that is the general equation. Notice that h and k are both being subtracted. It means that if hk is 0, 0, the origin, then your equation is just x squared plus y squared equals r squared for that. If they do have numbers, you'll see how that plays out coming up. So example 1, write the equation of a circle centered at 9, negative 3 with a diameter of 8. So let me just pull down that standard equation for now so that we have it in front of us and you can see how things play out. Okay, so let's deal with the left side first, x minus 8 squared and y minus k squared. Well, here's h, here's k. Those are the two parts of our center. H and y x and y are usually going to stay what they are. They're going to stay x and y. We can plug in points to see if they're on the circle, but that's about it. So, starting out with the left, I am going to put down x. Now you'll notice that h is 9. So this one's pretty simple. I'm just going to do x minus 9, and I have x minus h squared. Notice that k is a negative number. So I'm not going to do y minus 3. I'm actually going to do y plus 3. Because if I'm doing y minus k, that means I'm doing y minus negative 3. Minus negative 3 turns into plus 3 squared. And then we need the other side to be the radius squared. Well, in a circle, if we know that the diameter is 8, that means that the radius is going to be 4. So if we want the radius squared, that's going to be 4 squared, which is 16. And that is the equation of that circle. So there's that one. Example 2 is a little trickier. What they tell us is that we have a circle that has endpoints 2 negative diameters that has a diameter that has endpoints 2, negative 10, and negative 4, 6. So if we were to kind of make a sketch of the graph, 2, negative 10 would be somewhere around here. Let's just label that as 2, negative 10. And negative 4, 6 would be somewhere around here, negative 4, 6. So, we're going to need to do a few calculations to figure out some of these things. Remember, what we have going on is there's a circle that's going through these points. The center is going to be right in the middle of them. There's our diameter. So we need the coordinates of this point. So we have our center, and then we also need to know the length of the radius. And we can figure that out either right away, or we can figure that out after we find the center. Let's find the center first. The center is going to be the midpoint of the diameter that we have here. Remember this, the center is always in the middle of the diameter that there is for a circle. So we just need to use midpoint formula. Midpoint formula is the one where you add the x's together, divide by 2, get your x coordinate, add the y coordinates together, divide by 2, get the y coordinate. So we'll have -4 from the point up top, plus 2 over 2, comma, 6 plus -10 over 2. So that's giving me -4 plus 2 is -2 over 2. 6 plus -10 is -4 over 2. And that means that my midpoint is -1, -2. Which means that that's the center of the circle. -1, -2 is the center of the circle. So, if we want to find the length of the radius, we have a few approaches that we can take. Like I said, we know that the center here now, we know it's -1, -2. The easiest way to do this would probably be to just use distance formula. And you can use it with any 2 points here that you want to. I would say the easiest would be the center and one of the other ones. So what I'll do is I'll use, let me circle them, I'll use the center right here, and I will use this point down here with distance formula. So let me set that up. Square root of, let's start with -10. So we have -10 minus -2 squared plus 2 minus -1 squared. So let's make that look a little nicer. -10 minus -2 is -10 plus 2. So we have the square root of -8 squared plus 2 minus -1 is 3. So we have 3 squared. That's giving us the square root of 64 plus 9, which is the square root of 73. 73. And I'm actually going to leave it like that. I'm not going to turn it into a decimal. You'll see why in a moment. We have everything we need now to write the equation. So, what we're going to do is we're just going to set it up like we did. We have x. Our center again is this right here, -1, -2. Since the value of h is -1, we're going to have x plus 1. Remember, it's going to switch. It's going to be the opposite basically there, squared, plus y. Same thing with k. It's -2, so it's going to become plus 2 in the equation, equals, and remember, we need our radius squared for this last part. Well, from our distance calculation, we figured out that our radius was the square root of 73. If I want the square root of 73 squared, written like this, remember that squared and square root cancel each other out, so that's just going to be 73. We get that from this. So that's our equation. This example was quite a bit trickier because we had to use some of our old formulas. We had to use distance formula, we had to use midpoint formula, but in the end, we were able to figure it out. And it requires a little bit of problem solving, but problem solving is a really, really important skill for you to have anyway. So, that's good. Those are the 2 examples on the front. Let's move to the back. Now this one you gotta kind of work backwards. On this one. So let's see what we have. You'll notice that we have -5 here, and you'll notice that y is by itself here. So the -5 in the equation for x is telling us that the x coordinate of the center is 5, because we're subtracting the x coordinate, and the x, we're subtracting 5. The fact that there's nothing next to y means that really there's a 0. It's plus or minus 0 next to the y. So that means that the y coordinate for the center is 0. if we're given 8 for the radius, that means that 8 for radius squared, that means that the radius is the square root of 8. You just take the square root of whatever you have there. Sometimes it'll work out to be a nice number, sometimes it won't. Now I'm noticing that on this particular example, at least on here, on the screen up here, it did not come through very well. So I don't really have a copy of it, but this one's going to work in a very similar way to kind of to examples 1 and 2 combined. I can't really see where the center is on my copy here, but let's say the center was right here. You would just use the coordinates of that center to help you find the first part of the equation, and then you could even go straight up here, measure what the radius was, and then use that to find the second half. I think you've seen enough examples so far that have done something like that, though, so we can skip that one anyway. All right, so in this one, we want to graph this circle. We can use our equation, these parts, to tell us where our center is. We can see the center is going to be -1, 3. So -1, 3. So I'm going to, if you're using pencil, put that in really lightly, because the center, remember, isn't actually part of the circle. It's something we use to help graph it. And then we have equals 25. Well, if we want the radius, we'll take the square root of that. Square root of 25 is 5. So what I'm going to do is I'm going to go in the 4 cardinal directions, basically north, south, east, west, from the center, and I'm going to make those points. So here we go. 1, 2, 3, 4, up. 1, 2, 3, 4. Oh, I should have gone 5 up, sorry. Not 4. Let me erase that other dot. 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 down. And 1, 2, 3, 4, 5 to the left. And what I'm going to do is, just freehanding, I'm going to do my best impression of a circle I can. Clearly not very good. Maybe you can do better with it. If you have a compass, you could always use that, I suppose. But there you have it. That's generally the graph of that circle. And that's how you do it. You just use the equation. It's not too bad to do once you realize what everything stands for. Last example we have, does the point 1, -4 lie on this circle with this equation? All we have to do to check it out is plug this point in for x and y, and if it works, then it's on the circle, and if it doesn't, then it's not. So we'll have 1 plus 5 squared plus -4 plus 4 squared, and we're checking to see, does this equal 36? Well, 1 plus 5 is 6, that's squared, plus 0 squared equals 36. 6 squared is 36, 0 squared is 0, so 36 does equal 36. So the point 1, I don't know what I was drawing there, hold on a sec. So the point 1, -4 is on the circle. All right, that is it for chapter 10. If you've watched this and you've watched all the other videos, you are probably good to go with the information that you're going to get from me. So, good luck on tests, projects, whatever it is you're working on. We can talk more about any of this in class. So, see you then. Talk to you later.